Okay, so now we're going to add some code to find the flushcut window. So let's just hide that for a second. So what we're looking for again is this combo box here, which has an edit control attached to it. If we look on SPY, we see it's there. I'm going to keep the app running so we can see the window handle is this. So here's one we're looking for. So how we're going to find that is to look for the main window, and I'm going to look for it by the name. So it says flushcut space capital CNC, and then there's a space and a minus sign, and it changes this to either file name or no file load and stuff. And the reason I'm going to do that is because I've seen other windows that pop up that also say flushcut CNC, but they don't have the little space minus, and that'll help differentiate them between them. I mean, you can also check to see if it's a child of the desktop and stuff, but this just seems like a good way to do it. Okay, so let's go back to Visual Studio and add the code for that. So we're going to go into the dialog, because we're doing this inside the dialog. Visual Studio's created all this for us here, and so that's ready to go. And what I want to do is we want to fetch that based on a timer value. So every so many milliseconds we're going to look for that window, and I'm going to keep looking for it as opposed to just finding it once in case the window gets closed, something happens. You know, it's better this way. I feel that to keep checking the window, because it's a very small system overhead to actually find that window. So the way that I'm going to do that is I'm actually going to add an on timer routine. So in Visual Studio MFC you have all these events, like onPaint is from a Windows message called WMPaint that gets sent out, that gets translated into this dialog paint message that tells it, you know, when to draw these things. Like this one here says if it's minimized, it draws this. Otherwise, it calls the base classes paint function. And you can see, like here, for instance, that's a message for us. It's going to be that button handler. If we look at the top here, you'll see that they got added in. There's DDX controls, and there's the click messages that mean call these on. So call these functions when this ID is clicked. And so we're going to do one for timer, and the easy way to do that is to add it into the dialog through the class wizard. So we'll bring up the class wizard here, and what we're looking for is the timer. And you may hear me say, like I said, WMPaint, for instance, is listed. There's the onPaint function, which is calling already. That on already exists. As you can see, it's highlighted in bold. So you can do that, and you can look down here and find WM timer and add a handler, or you can go to the virtual functions and look for it down here. And I believe that, so you can see, like, not all of them have pre-created ones. So these are the ones that already exist. So we can just, you know, type it in, add it ourselves here. But the best way to do it, just go here and click add handler, and now it's made an on timer function. It calls the base class to handle it. So let's add some code in here to find that window. So what we want is we want the hwind, which is the Windows handle. So let's create hwind, and we'll call that the flush. And I'm going to be very verbose again. Equals. And we'll make a function because we're probably going to use it elsewhere. So we're going to make a new function called that, and it's going to return an hwind for us. So let's just stick it up here for temporarily. Get flash cut hwind. It doesn't take any parameters. Just default anyway in there, about there. So let's make our local hwind. Doesn't really need to be initialized there, but it's good practice. And we're going to use what's called enum windows. Enum windows is a way to run through each of the windows in the system looking for something. So it's going to call a function for us, a callback, every time. Okay, so what that's going to do is call this function when I write it, and fill in that parameter. We're casting it because it doesn't care what it is. So we're going to, in our enum function, we're going to handle that. Okay, so our email function returns a boolean. It's a callback, which is a specific type that's going to be defined as, you know, the standard call is like a fast call, or depending on the RB. So we know the parameters for that are going to be, Windows is going to call it with these for us. That's kind of the Windows ways to do things. Okay, so oops, get rid of the function there. So let's put that in there. Okay, so now we've got the function that this is a built-in Windows function that's going to call this function for every window in the system with the window it finds hwind and a parameter for us to fill that in. Okay, so what we want to do, we want to find the buffer. So I'm just going to make a simple little hard-coded buffer there. I'm going to use the 8-bit type. And then we're going to do this. So I want to get the window text, and I'm using A because I'm using the 8-bit. So there's Windows can do Unicode MBCS, which is a 16-bit or different string type. And if you do get window text, it chooses the right one for the build. But I want to force it to A because I want this to go as an 8-bit string, and a lot of the titles and stuff like that can only be that way. So, but I want to make sure that I'm getting back an 8-bit ASCII Z string. So we're calling that with the window that enum has passed into us, the buffer, and then obviously I want the size of that buffer. Okay, sorry, there we are. So what this does is gets the title of the window. Okay, so we have text length. So if, what we're going to do now is if text length, and it's just a string. We use strict, but I think strict will do it at the moment, which isn't one of the Windows ones. That's just kind of on the C standard library one. And then we're going to say the name of that. So what did we say it was? We're going to say it's flushcut CNC. We're going to copy that exactly. Now we know it's going to be in Unicode. In ASCII Z. So that's why we're going to keep it that way. Okay, so what we're basically saying here is an extra bracket there, I think. Yeah. You can do control square brackets to match pairs there. Alright, so that means that check if window title matches. If it's in here, it should. Also made any glaring typing errors. Params. Now we're going to fill in the return value here, and we're going to stop the search. So this needs backwards, but we don't want it to continue the search. So we found it. There we go. Pretty obvious there. Seems counterintuitive, but that's what we want to do. Okay, so what we're saying is if there was a title, like if it's not a 0. And if this buffer contains this string, even though it's really only ever going to be the start, so you know, strict is probably better. But let's go with that. If not, let's clear out the parameter. We're just going to typecast it here. Okay, and then return. We want it to continue. Keep looking. There we go. Okay, so that's our function to look for the flushcut CNC window. So here we call this, and it will tell us what that is. Now we're going to return it, and so that will return the value. Okay, so find a flushcut CNC window if it exists, and return its hwind. You can put in more parameters here, like it's nice to do it as a style. My auto helper's gotten a bit crazy there. Put it in the doxygen style. This is where things are being too helpful. You know, we add parameters in and stuff like that. It's always good style, and return, etc. Or no. And done. Like that. Okay. So now that we've got that, we can now go in here and find it. So in here we want to say, so that there now should be that. Okay, so let's say if flushcut window equals null, in other words, can't find it, we're going to set that status line. Set window text, and this is, again, I'm using Windows stuff here. And this time we want to let Windows choose which, if we're running Unicode or not, or MVCS, even though Visual Studio 2016 there. Can't. Oh my god, typing's all over the place. Findflashcut window. And that just lets us know that for whatever reason the app can't find it. And then we'll just drop out early. Well, actually we won't drop out early. What should we do? Okay, let's just leave it at that, so that we can run the base class. We'll stick that on an else. Okay. So now that we have found it, what do we do with it? Well, we're going to have to look for the, excuse me, there's a couple of another command that we want to find in flushcut, and that's this guy here. So the spindle on off, which if you click it, it does this and changes. See how it changes the text? So we want that too, because we want to be able to control it. So we need that button too. And again, if we use spy, we can either look through that tree and just see it, or we can just drag it. Actually, you can't. The way I've got it here now, I can't drag it. I'll just move that down, and you'll see there, and there it tells us the handle, and it's a button as we expect it to be. Okay, so let's do that. Sorry. Alright, so what we're going to do next is find that. Now everything is a window here, so that one is a button window. So what we're going to do is we're going to find that window. We're using the base window. So what it's saying here is find me a window that matches these parameters inside. So it's a child window. The underscore T is a little macro that we have to use the exact text that we're looking for. But yeah, the underscore T is a macro that either sets it as to be an ASCII Z or a Unicode string or MVCS. Alright, so what we did there is we say create a button, Spindle, find window extended versions as more parameters using the window that we just found that matches this class, which we saw in spy, and we know it's a button anyway, and that text. So I think that's the correct text. So what we're saying is, does that one exist like that? If it doesn't, let's do it again. I'm just going to go basic here, recopy that. Okay, so now we say, okay, try to find button in off mode. Failed. So look for on mode. And what we're trying to do is find the current status of that button. We know it exists as long as it's been turned on in the GUI. But we should say if button spindle, whoops, bouton, the bouton equals no. Fingers are all over the place today. We do that status thing again. Can't find spindle on off button. Okay. There we go. And at this point, want to drop away. Okay, so we can break out of it. Drop to the next part. Okay, so where are we now? So at this point, we should have our everything in there. Let's not else that because that doesn't really right. It's going to be here. Let's see, can we do it? We'll move it out. Yeah, that's what I thought. It was just one of the nested ifs or one of the reasons for go-tos, but we won't do that. Just move this up. That will make it a lot easier. The other way to do it is just to invert the if so that our failure is it starts off. Obviously I'm writing this as I go along here, so I would redo it. So we just want to drop out early here instead because it can't break out of it because it's not there. And same thing here. Let's just break out of it early here. Okay, that's better. Should definitely reorientated that a little bit. Okay, so now that we've found these, we know something about the state of it, and what we want to say is spindle equals true, because we're going to make a new thing. The spindle is on. There we go. Okay. And if we find this one here, which is here, we want to say in spindle equals false. The spindle is off. Overcommenting again. This is a really bad habit, I feel. And now what we want to do is make that it's complaining that we haven't got it. So let's go into the bar class here. The definition of it, and we're going to add our own boolean there, and then we're going to go to the constructor and spindle, and we're going to initialize it here. And just because of the type of app this is, I'm just going to do that as well. Double initializing it, just the extra sure. Okay, so let's make sure it compiles, we're good. Okay, now where were we? Back down here. Okay, so the idea is that it looks for the spindle on and off and sets this value dependent on whether or not it can find the text saying it's on or off. So by the time it reaches one of these, single step it. Oh boy. I can't. So I have to set the breakpoint here, like that, because I'm using the capture software is using my key. So we're going to say, let's start debugging. Oh, you know what? Nothing's calling the timer yet, so let's add a quick... so the timer, even though we've actually told it there that we want to run it, we haven't actually told it to call it yet. So we want to set the timer off. Let's go back to our init function. And just temporarily we're going to pop this in here. So we're going to say set timer. This is the event, which is quite one. Doesn't really matter at the moment. We're not using anything like that, and we run it at 10 milliseconds and no parameter or no function to call. So we're just going to call the default function. And there goes my phone again. I think it's people talking on Google+. Okay, so now if I run it. Okay, so now it's going to look. Okay, now that I've reconfigured the capture software's hotkeys, I can actually use Visual Studio again. Okay, so we just call this, it's stopping here, and now we're going to enumerate through the windows looking for this, so let's stop it inside here, and you should see that we'll go through. This one isn't going to do anything, so let's move our breakpoint in here, and lo and behold, it's found something 102 length. There's the name of our flushcut. There's at each win, so I think it's C28 there. So let's look back in Spy. I mean, we know it's there because of the title box, but just because, as you can see, it is C28. Okay, good. So that means that's working. So we're going to step through disassembly now, because that's the system call that it's calling. So eventually it'll run to here. So let's bring it back to here. It is not null because we found it. Okay, now it's going to try and find the spindle on off button, and if we look back again at flushcut, you can see it's an off at the moment, so it should find it. And it found something at E1E. Again, we can look in Spy if we really want to. Not sure where that one is. Everyone's chatting on Google Plus about VFDs and how inaccurate things like the shape co are. So there we go, spindle off button, and you can see that's E1E. So yeah, it's a class bouton for E1E. Okay, great. So it has found it. So it should skip down here, and the spindle is false because it's off. We have a false spindle. Okay, great. So back into, and it's just going to keep running that every 10 ticks or so. Okay, nothing super interesting yet, but we're that's the basis of it. So not quite sure what. There we go. A little bit of delay there. Okay, so good. So if we get down here, we found this bundle. We found all the windows that we need to find. So what we need to do now is look for the rest of it. Okay, we want to find I think the track bar next, which is this guy here. So we want to find this guy, and there's a reason for that. One, it helps us to find the next element in the GUI, because that's a little trickier. So we know that this is kind of this text, this, and this are all kind of in that order. So what we're going to do is find this one, and then iterate to that, because we know from looking at Spy that if we find that track bar there, which if I highlight it, we know that the next control is this guy. Again, highlight it, and it's sub. So these are actually the same control. The edit box is, the combo box has an edit box inside it, or as I like to call it, the combo box. Okay. So let's find the next part. So we need another hwind, which is the Windows name. Spindle text. So let's find that window. And again, we're going to use the flushcut window handle, which I forgot what I called that for a second. We're looking for that static text above it, which says Spindle RPM. Again, I'm using these macros that define the string differently, depending on if you're running Unicode or not. Okay, so what we're saying here is iterate through the child windows. or sub windows of this. I'm looking for this guy here where it says Spindle RPM. Now you can't change that, but obviously don't change it because then this wouldn't work. I mean, we could do other ways. This is just kind of works. So let's make sure that equals no. And you can do not as well. And we're going to say something like set that status message to set window text. And that's either because it's been changed or because they haven't turned it on because it's an option. But of course we're assuming that has all been done, but we want to make sure that of course we don't continue any further because that would be bad. Okay, so next we're going to do is get to that the track bar. And there's our super long name, MSCTLS, Microsoft Controls, track bar, because we're being very obtuse here. Get window. Now we can use a much simpler one here because we know that it's the next one after this. And this just says GWH wind next. And obviously we're using features of Windows that you probably have to know. But this basically just says get me the next window handle. Again, if you look in SPY, you'll see the next one is the combo box. And, you know, this is very specific to this program and very specific to this GUI. If they change the code, and they haven't changed it in like 2 years or something, so now would be the time. And then again, if we can't find it, we inform the user. It's been, my helper macros have been very helpful. That's what most of the backspace is. Count. At this point, it's very unlikely that it wouldn't find that, so but we should do it anyway and break out of that timer. Okay, so now we know the handle of the track bar. We just need to look for this. We need to look for the combo box next. But while we're in here, since we have this one, let's find the position of it. The position of it's not helpful because it's just going to be like 1 to 100, not an actual RPM value. So what we need to do now is kind of go in here and grab the position of that, and the way that we do that is just to interrogate it through the GUI, and this is just a standard Windows call. So we're going to say the current RPM slider. I give them very long variable names just because. And what we're going to do is, and this is how Windows works, it's a message pump. We're going to send a message to that control that we found here. And we're going to say, where are you? Which is just this. We don't need those parameters, it's just extra. So sorry. So what this does is, and let me get rid of this just to open up a bit more space. This says, sends get position to this, so that will return this. Now, what's interesting about this is there's no easy way for this error message here. So how do we know it didn't work? Because we could say, is that 0? Well, the RPM could be 0. It could be -1, I guess, but it's not. So what we need to use is get last error, and get last error is like no in Unix and also MS-DOS. So we want to say if this wasn't a success, and that's what we should have been doing before. Post success. That's kind of ironic, isn't it? We're going to set that little status bar at the bottom again. Set window text, and there's my helper being helpful again. Not helpful. Couldn't get slider position. Okay. I hate punctuation. Okay. Now what's interesting about this is get last error is that send message, because it's just part of the Windows message from it doesn't set any error codes. So it can still listen there. So what we have to do is we have to set a error here of error success. Again, I can't spell success, look at that. So what this does is preset error code because send message doesn't change it to error. So it only changes it. Good lord. It only changes it if there's an error. It doesn't change it if it's successful. So we have to set it so that we know. Okay, so at this point we should know where that slider is. And the reason that I'm doing that is I'll get into later a little bit. But what we want to do now is find the next window. So we want to have a spindle speed edit box. Okay. Let's see. So we know that from before that this one is the it's going to be the next one. It's going to be the next one after the trap bar. So we're going to do this same thing again, except that we're going to use so we're iterating through them. Okay, so what the idea is for this is we're saying that after the trap bar, and we can confirm that it's the combo box. Okay, and we can see the combo box has that value we want as well, so we don't actually have to go down to the edit control. Okay, so at this point now we have some very long variable names, which kind of getting a bit nuts. Same thing again, and let's just copy and paste this because it's very verbose. Couldn't get the combo box, and the user's going to look at this and like, the hell's a combo box? But since this is probably only going to be me that ever uses this ever. Okay, great. Now, so just to be extra sure, because we don't know much about this, I think what we want to do is check its class, and that will at least give us some indication that it's the right thing. So we need a t-char because it's I don't think there's any class names longer than that, but there could be. And that's one of the bad things about these types of strings. So bring that in there. So we're asking that control that we just found to fill in that value we just made. Not sure what's going on outside. Oh, it's a dog. They're barking. Okay, and all I'm doing here is making sure that the function we're calling knows how much of a buffer space we've got. So what this will do, fill in this with that class name here. So now we know this should contain, if it's the right one, it should contain combo box. So let's mix our APIs, because we're using possibly Unicode, and this one is Unicode sensitive. Okay. And again, we're back to this. Oh, we're missing a bracket, I think. Yeah, too many. What have we got? Too many brackets. Excuse me. And yet more. What's I use? Fine. So that way we can see it's a different error. We know where it is in the code when our dutiful users bring it in there. Okay, so at this point we're pretty sure that now that sorry, that this is the combo box we're looking for. This is the droid that we're looking for, huh? Okay, so now we need to get the text of spindle speed, and let's do it this way. So what we're looking for is this value that it's set for in that combo box. So basically, what we're looking for is that. So what we're going to do is we're going to send a message to it and say, well, what's the text that's stored inside of you? Give it to me, please. And we're going to run that same error again. So set last error again, as I mentioned before, that I apparently, there we go, successfully spelled success. Pretty awesome. Okay, and we need a I think we've already got result defined. If not, we shall make one. It's been ridiculous handles, help me out. Okay, so we're going to send a message to the edit box. Well, it's actually not the edit box, it's the combo box, so we'll have to fix that in a second. Because initially we were going to go down to the edit box, but we don't need to. We're going to say what are the context of it, so we're sending a message saying please tell me what your text is, and then we need to put it in somewhere. So I'm thinking about it. Didn't do that already. And let's just make another buffer here. You can see be Windows flipping Chicago-y stuff going on. Okay. So I watch paint dry back, which is interesting because there's painters in my house at the moment painting stuff, painting walls. It's not that interesting, let's be honest. Hello, doggy. I'll point to that. So, a quite long little thing there is saying, send the message to the Spindle, not elbow box, it's actually a combo box. Get your text, and that's how much space you've got to write into and store it in there. So basically, if we do that, if get last error again, equals error success. I need successfully spell success again. Yes. Okay, so now we want the RPM value, and we'll make a new one of those as well. And we're gonna, because it's a string, and we know it's an int, we're going to convert it. Right, so this basically takes a possibly Unicode value string and converts it to an integer value, which is here. I want that one around for later, so we're going to put that one into our base here. And it's an int, and we can use the uint style as well. What do you reckon? It'd be very fast spin all that. And of course we can just to the global. Okay, great. So again, the other thing is go back to our constructor, which is here, and we're going to initialize the value. Let's make it 0. Again, I'm going to put it down here, just because it's this app is very sensitive to anything that goes wrong, and there's no chance of that happening at that particular part, but we're being extra careful. Alright, so now that we've got down here, we should probably check to see if any of this has actually worked. Where did we get to before? So let's put a breakpoint on it, and we'll run it, and there's build errors, oh my goodness. What? Oh. We haven't included standard in. Let's just make it in for now. Okay. Just to be cheeky. Terrible thing to do. Just add standard in. Header. Okay. So we got the flushcut window, we're good there. We think the spindle is off, which if we look, it is. Which, you know, now there's our track bar. Can't remember if we verified that one already. I think we did. Yeah, it is. So we're okay. Now we're asking for the slider position. It says it's at slider position 40. As I mentioned, it's not super helpful because we don't know what that translates to. It's just under 2000, so it's like 1900. But at least we know that it's likely to be working since it is a 40 value. We can verify it later. And then our edit box is free EO8. Sorry, combo box. Keep mixing it up, don't I? Because I haven't changed this. I'll refactor this in a minute. Okay, we're getting the class name now. It's that combo box because it is a combo box, not an edit box. Is it not that? And now we're going to send it a message and say, what's your text? And 1800. And if we look, ta-da! It is in fact 1800. How clever. Okay, great. And now we're going to convert that to an actual int value. And great. So let's stop the debugger because we don't need any more. Okay, great. Okay, so now that we found that value, what should we do with it? If we remember that we have this RPM here, that translates into this edit control here. I'm keeping them different because one's the GUI and one's the actual value that we use later on when we set the speed. But for now, we can just simply do RPM dot, let's see, I do set text. So, to SC buff. That should be correct. Okay, so let's run that again. We'll take off the breakpoint, we don't need it. And you'll see it's changed to there. So let's bring up flushcut and move that to a point where we see it. And look at that. As we change it, it changes. So that's good. Great. So let's exit that. And then the other thing we can do is, now that we know that, we can actually change the spindle as well. So we know this variable here, which I think we made global, we did, well, global in the class. We can change that too. So we want to be in here. And let's update this guy here. So we're going to change that one to match the flushcut one. So that's the spindle status. And what we're going to do with it is we're just going to say, we can do a switch or this. So let's see, spindle. I think that was the right one. So we're going to say, yeah, it was. I'm going to copy the whole thing in. So if mspindle equals false, that means if it's off, we're going to set that window text to be spindle. And let's copy exactly what it says in the flushcut. And of course, unless the user changes it, we could code that in, but it seems excessive. No one ever changes the defaults. Alright, so I think that's right. Reflect the spindle status in the GUI. I wonder if this is Ave, how Ave developed his language by just, oh, we got a spindle on there, so what did I do wrong? Oh. Obviously did something wrong. Oh, duh. And there's one of those interesting things. You probably saw that as I was typing it. That is equality. That is make it equal. So that is changing it. So what's good about that is, good trick is, if you code like this, which is, typing errors. If you do this instead, just a little coding tip. We should hopefully that is now off. Oh, there we go. So let's just move it over here and make sure we're doing it. spindle on, spindle off, spindle on, goes on, light goes off. Okay, so what that means is if I now do this, you'll see it won't compile because you can't assign anything to false. So it's kind of a neat trick to do that, but it is definitely a habitual thing. If you used to coding it the other way around, it's very hard to kind of switch, but it is a good idea because it will catch like subtle bugs like that, because that is can be a very subtle bug. So yeah, first one so far, but it happens. Okay. Now what's interesting about this is every time we're coming through, we're setting the values. We don't need to. We can just change them. Oh, no, the dog's got a squeaky toy. We just change them based on the last value instead. So what we want to say is, if we have a static, yeah, the dog is chewing on a thing now, and we just say if RPM not equal mRPM, then do this part. Okay, and then inside here just set RPM equals mRPM. I didn't choose particularly good variable names there, but then the idea is that it will only update that one based on, we can also make that -1, which it will do on the very first time around. Okay, so let's have the same thing for the spindle state, I think, as well. Or do we need to, so we only update it there because we can move it, yep. So the RPM can change, but that, or not change. So this should be reflected differently. So we can also say update that spindle state only on a change as well, which will cut down the amount of the stuff going back and forth. So we're basically just catching the value there and sort of saying rest spindle state, which is a slightly nicer sort of. So if, I don't know what the dog is doing. Not equals current state. Actually, that is a bool, isn't it? So we'll change that in a sec. Sorry. Okay, so that can only be one or either, which kind of runs into an issue on your first one that it won't update. So I think we will just coerce that into something else. So it definitely isn't equal that. Right, because now we're getting a whining about it, that it's an unsafe mix, and it is. Okay, we just need to add that there, because we had it from before. So yeah, it's complaining about that. I mean, we can coerce that into there, which is naughty, but it'll stop it, stop that error. And then hopefully if we run it now. Oh, forgot to update the spindle state. Okay, there we go. So now it's not flickering because it's not constantly updating it. It will only update it on a change, he says. Okay, great. Same for this guy. So we're not flooding the Windows message queue, which is important on CNC machines, so we don't want to overtax the system. But yeah, not the most elegant way to do it there, but it certainly works for the moment. You can come in and clean it up later. Oh, the other thing I was going to do before I forget is do this. You don't probably have this part, but this is kind of a nice feature. It's called Visual Assist. Everyone should use it. And there we go. It just renamed them all for me. Should be built into Visual Studio. It's kind of, but it's a lot easier to do it that way. Alright, let's make sure it did the right thing. Everything looks okay. So there we are. We now have an app that will at least track the spindle. We can't change it there, that would be silly. I mean, we could. You could actually turn this into just a spindle control app just by this, So 3000, 0, nice and quick. We can change that by that parameter set on the add timer, which we're going to change in a minute anyway. And there we are. Next thing to do is to send all that information to the drive, which is probably slightly more interesting. But yeah, great. Let's stop there for now. Okay, so now that we found that value, what should we do with it? If we remember that we have this RPM here, that translates into this edit control here. I'm keeping them different because one's the GUI and one's the actual value that we use later on when we set the speed. But for now, we can just simply do RPM dot, let's see, I do set text. So, to SC buff, that should be correct. Okay, so let's run that again. We'll take off the breakpoint, we don't need it. And you'll see it's changed to there. So let's bring up flushcut and move that to a point where we see it. And look at that. As we change it, it changes. So that's good. Great. So let's exit that. And then the other thing we can do is, now that we know that, we can actually change the spindle as well. So we know this variable here, which I think we made global, we did, well, global within the class. We can change that too. So we want to be in here. And let's update this guy here. So we're going to change that one to match the flushcut one. So that's the spindle status. And what we're going to do with it is we're just going to say, we can do a switch or this. So let's see, spindle. I think that was the right one. So we're going to say, yeah, it was. I'm going to put the whole thing in. So if mspindle equals false, that means if it's off, we're going to set that window text to be spindle. And let's copy exactly what it says in the flushcut. And of course, unless the user changes it, there's not, we could code that in, but it seems excessive. No one ever changes the defaults. Alright, so I think that's right. Reflect the spindle status in the GUI. I wonder if this is Ave, how Ave developed his language by just, oh, we got a spindle on there, so what did I do wrong? Oh. Obviously did something wrong. Oh, duh. And there's one of those interesting things. You probably saw that as I was typing it. That is equality. That is make it equal. So that is changing it. So what's good about that is good trick is if you code like this, which is, look at these typing errors. If you do this instead, just a little coding tip. Hopefully that is now off. Oh, there we go. So let's just move it over here and make sure we're doing it. Spindle on, spindle off, spindle on. Goes on like goes off. Okay. So what that means is if I now do this, you'll see it won't compile because you can't assign anything to false. So it's kind of a neat trick to do that. But it is definitely a habitual thing. If you used to coding it the other way around, it's very hard to kind of switch, but it is a good idea because it will catch like subtle bugs like that, because that is can be a very subtle bug. So yeah, first one so far, but it happens. Okay. Now what's interesting about this is every time we're coming through, we're setting the values. We don't need to. We can just change them. Oh, now the dog's got a squeaky toy. We just change them based on the last value. instead. So what we want to say is, if we have a static, yeah, the dog is chewing on a thing now, and we just say if RPM not equal mRPM, then do this part. Okay, and then inside here just set RPM equals mRPM. I didn't choose particularly good variable names there, but then the idea is that it will only update that one based on, we could also make that -1, which it will do on the very first time around. Okay, so let's have the same thing for the spindle state, I think, as well. Or do we need to, so we only update it there because we can move it, yep. So the RPM can change, but that, or not change. So this should be reflected differently. So we can also say update that spindle state only on a change as well, which will cut down the amount of the stuff going back and forth. So we're basically just caching the value there and sort of saying rest spindle state, which is a slightly nicer sort of if, I don't know what the dog is doing. Not equals current state. Actually that is a bool, isn't it? So we'll change that in a sec. Sorry. Okay, so that can only be one or either, which kind of runs into an issue on your first one that it won't update. So I think we will just coerce that into something else. So it definitely isn't equal that, right? Because now we're getting a whining about it, that it's an unsafe mix, and it is. Okay, we just need to add that there, because we had it from before. So yeah, it's complaining about that. I mean, we can coerce that into there, which is naughty, but it'll stop it, stop that error. And then hopefully if we run it now, oh, forgot to update the spindle state. Okay, there we go. So now it's not flickering because it's not constantly updating it. It will only update it on a change, he says. Okay, great. Same for this guy. So we're not flooding the Windows message queue, which is important on CNC machines, so we don't want to overtax the system. But yeah, not the most elegant way to do it there, but it certainly works for the moment. We can come in and clean it up later. Oh, the other thing I was going to do before I forget is do this. You don't probably have this part, but this is kind of a nice feature. It's called Visual Assist. Everyone should use it. And there we go. It just renamed them all for me. Should be built into Visual Studio. It's kind of, but it's a lot easier to do it that way. Alright, let's make sure it did the right thing. Everything looks okay. So there we are. We now have an app that will at least track the spindle. We can't change it there, that would be silly. I mean, we could. You could actually turn this into a spindle control app just by this. So 3000, 0, nice and quick. We can change that by that parameter set on the add timer, which we're going to change in a minute anyway. And there we are. The next thing to do is to send all that information to the drive, which is probably slightly more interesting. But yeah, great. Let's stop there for now.